Welcome back to P3. Now we're going to talk about some exercises. Our exercises in this video will just be about integer exponents. Scientific notation exercise I expect I will do in the video part 3 for scientific notation. We will be using these laws regularly throughout this set of exercises, so if you're not familiar with them, I would suggest keeping them open. They are in the book early on in the section if you want to look at them there. They're also in the front cover of the book in slightly different form. You use X's and Y's instead of A's and B's, but if you look in the front cover of the book in the section Exponents and Radicals on the top left of the cheat sheet on the front cover, it is basically the same set of rules. But if you want the reference from the book, it is on page 19. Let's get to the exercises. The first problem we're going to look at is exercise 9 on page 23 of the book. All of these exercises are going to be in section P3. Starting off, this is just a problem dealing with the interaction of negative signs and powers. The key reason I want to do this exercise is to highlight the difference between A and B. This only really matters if it is an even exponent we're dealing with. If we're dealing with an odd exponent, and this will highlight that here, it doesn't really matter. But with an even exponent, you have to be careful because of the order of operations. If you recall from the order of operations, it goes parentheses, exponents, multiplication and division, and then addition and subtraction, which is where these signs would come in. Now, addition and subtraction are evaluated below exponents. So on this one, you would do the exponent before you ever consider the sign. So on part A, this would just be negative 3 times 3. So you just end up with negative 9. This one, you've got to be careful, because this one, the negative's inside the parentheses, so it is going to get evaluated with the square. So you'll get negative 3 times negative 3, and you'll get positive 9. Honestly, the place I see students mess this up the most is not on problems like this. It's when they try and take something like this and plug it into the calculator. Because most of my students would just say negative 3 squared. But that'll get you this. If you want to square a negative 3, you need to make sure it's in parentheses. So when you're plugging into a calculator and you want to square a negative number, make sure you put it in parentheses. Otherwise, the calculator will obey the order of operations and give you back negative 9 when you want this. And I've had a lot of students blindly trust their calculator and get the wrong answer because they plugged it in incorrectly. If you're doing odd exponents, like to the 3, it doesn't really matter because negative 3 to the third, you evaluate 3 to the third, you get 27, and stick a negative on it, it's negative 27. Negative 3 to the third here, you'd still get 3 negatives, which would simplify to be a negative. So in that case, that last 3 is barely a 3. There it is. In that case, you'd still have negative 27. So that would be fine. But just watch out for even exponents interacting with negative numbers. So here we just distribute. So 2 to the third is 8. 3 to the third is 27 times negative 27. And that just reduces So, oh, there we go. So that is just going to be negative 8. And we're good. Moving on. This is exercise 24 from page 23 of the book. This is really having you practice the addition and subtraction and some of the distribution rules of exponents. So in this first one, A, what you want to do first is to a certain extent up to you. I could add these exponents first and add these together, or I could start subtracting. I could subtract the 3 from the 2, the 4 from the negative 1. It doesn't really matter where you start as long as you obey the rules of exponents. So I'm going to combine the expressions on the top, combine the expressions on the bottom, and then worry about subtraction. So z to the 2 times z to the 4th will get me z to the 6th, and z to the 3rd times z to the negative 1 will get me z to the 2. And then I want to subtract. Now, you could actually subtract in either place. If I subtract on the top, it'll be z to the 6 minus 2. If I subtract on the bottom, it will be 1 over z to the 2 minus 6. They both end up giving me the same result, ultimately, because z to the 6 minus 2 is z to the 4th. Z to the 2 minus 6 is 1 over z to the negative 4th. Now at the end, I'd have to then flip this and get back to z to the 4th, because part of simplifying an exponential expression is to end up with no negative exponents. That's actually something good to remember. A lot of problems, they'll just tell you to simplify and they won't necessarily specify all the things you need to do. One of them is make sure the end result has no negative exponents left. Here, you have the option of combining these a's first or distributing first. I think I'm going to distribute the exponent through first on this problem. Don't forget, the 4 goes on the 2 as well. So this is 2 to the 4th, a to the 12th, and a to the 8th. 2 to the 4th is 16. A to the 12th times a to the 8th is a to the 20th. And we're good. And then here, on part C, looks like I have to distribute first. So negative 3 to the 3rd, z squared to the 3rd to z to the 3rd. Negative 27 z to the 6th times 2 z to the 3rd. 2 times negative 27 is negative 54. Z to the 6th times z to the 3rd is z to the 9th. That should be the answer. Let's hit the next one. I think this will be the last example of the video. We have 2 parts to this problem 38 on page 23. In both parts, we have a fraction raised to an exponent. So I certainly can distribute the exponent through to everything first. But honestly, I did that in the last problem, and I find it's usually a bit quicker if I simplify whatever I can inside first and then do the distribution. Your mileage may vary. If you prefer the other way, you're certainly welcome to. I just find as a general rule it's a little easier if I simplify first. So in that case, I would have to subtract these two s's. So s to the 2 minus negative 1 would be s to the 3. And I'll write that in the next step. On the bottom, I'm not doing anything with the 5. I might as well subtract the t's on the bottom, because that's where it's going to end up being positive. T to the 1, because no power means there's an understood 1, minus negative 4. So now that gives me s to the 3rd over 5 t to the 5th to the negative 2 and I think I have simplified all I can inside the parentheses. Now we distribute the negative 2 and we have s to the negative 6, 5 to the negative 2, t to the negative 10. Everything's a negative exponent at this point. So we flip all our factors from top to bottom. Remember, this is an s, not a 5. So I have 5 to the 2, t to the 10th, and s to the 6th. And the last step would just be to simplify that 5 squared. 5 to the 2 is 25. So 25 t to the 10th over s to the 6th. On part B, very similar. So let's simplify what we can before we distribute that negative 3 through. Can reduce away one of the x's. So I shouldn't have any x's left on top. On the y's, you move that, subtract that from the bottom, we get a y to the 5th on the bottom. And the z would move up top, because negative 3 minus a negative 4 would get you z to the 1. So now I have z over xy to the 5th to the negative 3. Distribute the negative 3 through. Say that 3 times fast. 3 through, 3 through, 3 through. Yeah, I'm already starting to lose the sound by then. Z to the negative 3 over x to the negative 3, y to the negative 15, and lastly we just need to move the factors with negative exponents between the numerator and denominator so they end up all being positive. Our final step would then be x to the 3rd, y to the 15th, all of that over z to the 3rd. I hope you enjoyed the lecture. Join me next time as we finish out the section with a discussion about scientific notation. Talk to you then.